Let me share my screen with you. Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so couple of things from the past lecture is that I think lecture 1 there is I made a mistake in lecture 1, and this is regarding proper subsets. So what I did later is that I was going through that video again, and I noticed that I made a mistake in the definition of a proper subset, so I edited that part out, and yeah, it's there. If you want to see that, you can go there, but I think I should discuss it again, so that you're you're not left out. Okay, so I'll again start with the definition. So the definition of a proper subset is the following. Let's say you have a set A, and a proper subset okay, so hmm, a proper subset, let's call that proper subset B. This B will be called a proper subset of A if and only if B has to be a subset of A first, and then B is not equals to A. This is what we mean by a proper subset. So if you want to take an example, okay, more people are coming, give me a second. If you want to take an example, well, let's call A equals to A, B, C, D, E. Let's have a set B that's called A, B, C. Now in this case you can easily recognize that B is a subset of A, and also the fact that B is not equals to A. So in this case we call B a proper subset of A. Okay, so yeah, that's basically the definition of a proper subset. Now what happens if you call another set C that's equals to E, D, A, B, C? Well, A and C, they're basically the same thing, right? The same set, because ordering doesn't matter in a set. But you can call C is a subset of A, but you also see that C is equals to A. So we say that C is a subset of A, but it is not a proper subset of A.
Sir, I have a question.
Yeah.
Sir, there are two same element in C.
Yeah, they have the
W
same
A.
they have the same elements, right? I mean, A and C, they have the same elements. A has A, B, C, D, E. Similarly, C has E, D, A, B, C. Yeah, you have the
Okay.
same elements, so these two sets are equal, right?
Okay, sir. Uh,
Yeah. So when you see that C is equals to A, you say that, oh, this is not a proper subset. So the idea for this proper subset is the following: that set that you are going to call a subset of something else, or so to say a proper subset, has to be smaller. You know, by small I mean the number of elements that they have in common should be smaller than the original one. For example, over here B contains 3 elements, but not all the elements of A. Okay, So first you have to check whether um, this B is a subset of A, and then you have to check whether it's equals to the given set. If it's not, then you can call B a proper subset of A. And if you want to draw some diagrams, let's say this is A, and any set inside it that is contained within A, let's call that B. In this case, this is a proper subset, but if it were something like this is A and this is B, you know, they're coincident on each other. In this case, A and B, they are not proper subsets to each other, or so to say, B is not a proper subset to A. Does that make any sense?
Yes, sir.
Do you have any questions?
No, sir.
Okay, so
No,
yeah,
sir. Clear.
this was the thing from lecture 1 that I wanted to discuss. I mean, I was giving the same lecture to section 5 people, and then I realized, okay, maybe I made a mistake while talking to you people, so I thought I should clear this up. Okay, people are still joining the meeting. Okay, so let's now focus on something new, but before we go to that, any questions from the topics in lecture 1? If not, let us begin lecture 2. This is the last lecture on sets. So I'll start from discussing family of sets. So what is a family of sets or set? Well, from the definition of a set, you know that set will contain elements, right? But it might happen that those elements are set themselves. It can happen, and in those cases we call the sets that contains other sets as elements as a family of set. So an informal definition would be something like this: a set can have elements or entities that are sets as well. In that case, we call it a family or just family of sets. So let's take an example. Let's call a set A, and it will contain elements like this: A, B, C. But now let's say I want to add a fourth element, but this time I'm adding a set. Let's say the set of 1, 2, 3, and then E, like this. So as you can see, this A itself is a set, right? And apart from this single entities, this guy over here is a collection of objects as well. So this thing itself is a set too. If this is the case, we will call A a family of set. Or sets, whatever you want to call it. If you want to take another example, let's say write a set B, you can have 1, 2 like this, 2, 3, A, B, comma C, and you can make many more examples like this one. But note that while you write these sets inside another set, this collection itself is a single entity. So this set B will have 1, 2, 3, 4, 5 5 elements, where 3 of them are sets and 2 of them are just some collection of objects. Okay, and B itself is a family of sets.
Sir, can you just please repeat it?
Okay, so you can have set elements as sets as well. Okay, so it's a set inside a set. In that case, you call the bigger set or the set that's containing um, the other sets as a family of set. Does that make any sense? That's the
Sir,
definition of.
for the example যেটা আপনি সেকেন্ডে দিয়েছেন for B, how is it 5 elements?
Oh, because this is a set, right? 1 and
Yes.
2.
Yes.
But now what you're doing is that you're putting this inside another set, right?
Yes. Yep.
And this set itself is that element, is another element of set B, right?
Oh yeah, got it.
So in that sense, it's a single entity. It might be a collection. You know, whenever we define a set, we say collection of objects. Now objects themselves can be a collection of some other stuffs, right? We don't give any representation to our objects, so they can be anything.
Got it. Thank you, sir.
Okay. Okay, any more questions? Okay,
No.
not.
Sir,
Yep.
sir, is it recording?
Yeah, it's being recorded. Let me check again, just for your query. Yep, we are on the record. So
Okay, sir.
okay, all right. Okay, I'll show you another example. This one is pretty interesting, but if you don't understand it by any chance, don't worry about it. Okay, because I'll use some terms that lies.
স্যার
Yep.
স্যার আমার এখানে ইলেকট্রিসিটি নেই, আমার ফোন ল্যাপটপে চার্জও নেই।
It's fine, it's being recorded, you can watch it later on BUX.
থ্যাংক ইউ স্যার।
Okay, so let me show you another example, and it's a pretty interesting one. So I'm writing this Z. If you don't know what this Z is, well, don't worry about it, I'll explain it in a bit. Okay, so this is also an example of family of sets. Okay, and what are these things? Well, this 0 is a collection of numbers like this. Let's say -100. -80, 0, then 2, 4, 6, 100, goes on forever. So I think you can guess what is this zero, what the 0 is, right? Well, this denotes the set of even numbers. That means any number in this form, 2k, where k belongs to z. Now what is this z means? Well, this z means the set of integers. And you can also guess the fact that if you take any even number, you divide it by 2, what do you get? You get a 0 as the remainder, right? Or so to say, bhagshesh. The remainder is 0. So that's why we put a 0 and put a third braces, just to indicate the fact that this is a collection of all the even numbers, or all the numbers that has a modulo 0 when it's divided by 2. This is just a notation. If you don't get it, that's fine. This is just a notation, that's it. Similarly, this one will contain all the odd numbers. So this is also a family of sets. Take any odd number divided by 2, you get what? A remainder of 1, right? Now the reason you put this third braces is to indicate the fact that these are called equivalent classes, and in some sense you can say 180, they are equivalent to each other if you consider the remainder when both of them are divided by 2. In that sense they are equivalent. So these collections, this 0 and 1, these are collection of equivalent numbers, and they can form a set which is denoted by Z2, and this set will also be called a family of sets, this guy. Sets, whatever. This is another example. So any questions from family of sets? If not, let me now define something called universal set. Yeah, just ask.
Sir, how is attendance measured? Like,
Let's talk about it later. Do you have any math questions right now, like, you know, from family of sets?
no.
Okay, so let's talk about it at the end of the class. Okay. Okay, so what is a universal set? Well, the sets that we will study most of the time, we can think of them as some subset, or more precisely a proper subset of a bigger set, and that bigger set is called the universal set. So let's say we have a set like this: 1 2 3, b equals to 4 5, c equals to a b capital A. Now if you consider a set U that consists of all these elements 1 2 3 4 5 and ABA, 1 2 3 4 5 A B capital A, you can easily understand that A, B and C are all proper subsets or subsets of U, right? So in this sense, this U will be called a universal set. And diagrammatically this will look something like this. Usually they use a rectangle to define the universal set. You can also draw a circle, it really doesn't matter. So this might be A, this might be B, and this might be C. Okay, that's how it works, the idea of universal set. Any questions so far?
No, sir.
Okay, so now we define something else which is called a power set. So what is a power set? Given a set A, the power set of A, most of the time it's denoted as P of A. To denote the power set is the family of all subsets. Let's take an example. Let's say A is equals to 1 comma 2. Now if you want to have all the possible subsets, what are they? Can anyone tell me? What are all the subsets of A? Okay, so let me just write it for you. The subsets of A will be the following. One is just 1, the other one is 2, the other one is 1 comma 2, and the last one is the null set. And if you take their collection, this is just your power set, and it contains all the possible subsets of A. Proper or improper really doesn't matter. This is your power set, the collection of all the possible subsets of A. Now if you take another set, let's say B, A comma B comma C, can anyone tell me the power set of B?
Can I?
Yeah, I don't know who wants to speak first.
Okay. I think I will go first.
Okay.
A, B, C, and then A, B, B, C, C, A.
Okay, slow down. I'm not that fast. Okay.
Sorry.
A, B, C, then what? A, B,
A, B, A, C,
A, C. Okay.
C, A.
C, A. But what's the difference between
Nah,
AC
it's
and
the
CA?
same thing. Nah.
Okay. So what's the next element after AC?
After, let's see, B, C.
B, C. Okay. Then what?
ABC.
A, B, C.
Then A, B, C.
A, B, C. Okay. Anything else?
No set.
That means the null
Yeah,
set,
no.
right?
Yes.
Okay, so let's see. How many of you agree with this answer and how many of you disagree? Is there anyone who agrees that this is the right answer?
Yes, sir.
Yes,
This is
sir.
my-
Yes, sir.
Yes, sir. This is the
Yes,
right
sir.
answer.
Yes, sir.
No,
It's the
sir,
right one.
এখানে 9টা হবে না?
Okay, if there are 9 elements, then what's the other one? I think we have 8 elements so far, right? 3, 5,
Yes, sir.
7, 8, yeah. So I think someone wants to say there might be 9 elements. So can you tell me what is the 9th element of the set? Okay, so no, there won't be 9 elements. It will contain 8 elements. In fact, there is a theorem, a general theorem that says if you're sorry, Sifat?
Oh, sorry, sir. It's I guess the theorem is 2 to the power n.
2 to the power n, yeah. If your set has n elements, then the power set will contain 2 to the power n elements.
Great,
So
sir. Thank you.
if your set contains n elements, the power set will contain 2 to the power n elements. This is a theorem, a general theorem. Theorem means something that can be proven. Now my question is, can you really prove it? You prove the above mentioned theorem. Is it possible to prove it? Do you guys have any ideas? How do you think we should approach to prove it? Any ideas? Anyone? So what should we do? Do we just, you know, take some sets with some elements and check whether it yields, let's say I take a set of 100 elements. Should I check whether the power set will contain 2 to the power 100 elements? Is that feasible? What do you guys think?
I guess no, sir.
Okay, so can we find any clever way of proving this? Because it's a theorem, right? Some people proved it, I don't know, 1,000 years ago maybe, or 500 years ago. So any ideas from you people? I mean, I want to hear, like, any ideas at all. What do you think? There might be many ways we can do it, right? But the easiest one is via mathematical induction. So how many of you have not heard of induction or mathematical induction? It's fine. I mean, even if you don't know about it, it's absolutely fine. Is everyone familiar with induction?
No, sir.
Okay.
No, sir.
Okay, so let me just give you
No,
a brief
sir.
idea about induction. So induction or mathematical induction. So the idea of the mathematical induction is the following.
Sir,
Someone was saying
no, sir.
something.
No, sir. It's okay.
Okay. So the idea of induction is the following. Let's say you are given some statement or some problem that you need to prove, and you want to check whether it's possible to prove it or solve the problem via induction. So in that case, what you would do is that there will be some sort of a statement, and that's the thing you will try to prove, right? So the idea of induction is the following, that first check your statement for n equals to 1 and see if it's true. If it's true, go to another step. We call the second step, or the second step of induction, and that is put n equals to m and assume. I think someone wants to say something. Please proceed. Oh, I think Preeti raised a hand, right? Preeti, you want to say something?
No, sir.
Oh, okay. So as I was saying, on step 2, put n equals to m and assume for n equals to m the given statement, that means the problem you're dealing with, is true. So this is the assumption part, you assume it, okay? Then on the last step, or the third step of induction, what you do is that now let n equals to m plus 1 and see if you can prove it true using the assumption in step 2. If you can do it, you are done. That's how induction works. So let us try to prove this statement via induction. So this is a proof. First things first, we're going to put n equals to 1. So let us take a set A that contains only one element, and it has a power set of what? The null set and the element itself, right? So in this case we have two elements. So for n equals to 1, the statement, that means if you have n elements, you have 2 to the power n elements in the power set, is true. It's true. Now let's assume for n equals to m, the statement that we are dealing with, I'm not writing the full thing, I hope you know what the statement is. Basically the statement is just if you have n elements in the set, you have 2 to the power n elements in the power set. So let's assume that for n equals to m, that statement will hold, or it's true. It's true. So what does this mean? Well, this means if now my set contains m elements, the power set P of s will have 2 to the power m elements. Okay, this is true. We are assuming that on the second step. Now for the last step. Well, at last step, what do? We just put n equals to m plus 1, right? So that means taking a set with m plus 1 elements, and I'm using the second assumption. So if I do that, well, our set had n elements, and the statement says that the power set will contain 2 to the power n elements, right? But on the third step, what do? We put n equals to m plus 1. So now our set will have m elements, m plus 1 elements, and the power set should contain 2 plus 1. I'm putting a question mark over here because this is the thing we're trying to prove. So that's why I'm doing this, and this is coming from the second assumption, or the statement, whatever you want to call it. So sorry, it should not be n plus 1, it should be m plus 1, because we are putting n equals to m plus 1. But here you can see that this can be written as 2m times 2, right? But what is 2m? This is the number of elements when number of elements in the power set when the set itself contained m elements, right? So what you can do over here is that you can just put m equals to n like this. You can either do that, or you can just write the number of elements. This is the number of elements in the power set in assumption 2, right? And we assumed it to be true. So just put n equals to n, and then you can just write n plus 1. It might seem very redundant because we started with this, right? And we also use the fact that n is equals to m plus 1. So it might seem very redundant. So again, if you use the equality, so whenever s has n elements, n plus 1, because we're putting n equals to m over here, this will say that the power set will contain 2n plus 1 elements. Notice that in assumption 2 we said if we have m elements in set S, the power set will contain 2 to the power m, right? But now we started with n, we put m plus 1 first, we did some sort of a pretty elementary algebra, and then we put m equals to n. There's another reason for putting m equals to n, because this is a dummy index. That's another way of saying it, but if you don't understand what a dummy index is, just ignore it. You can do this whenever you are doing induction. And well, this implies whenever you have n plus 1 elements, your power set will contain 2 to the power n plus 1 elements, and this completes the proof. I know it might seem very redundant, and some of you might not get it, and some of you are wondering, okay, is this important for our course? Well, it's not. Junaid Bhai asked me to show you guys some induction, so that's why I proved this thing, just to give you some idea about mathematical induction. Yeah, Protoy, I think you want to say something.
স্যার এরকম কোশ্চেন কি পরীক্ষার প্রমাণ করা জিনিস পরীক্ষা আসতে পারে?
not about mathematical induction, that I can guarantee you. I won't ask you to prove things using mathematical inductions.
Sir, also, is there any chance there might be theoretical questions?
Theoretical questions, well, not that much, because you guys are not mathematicians. So to get the most out of the course, I don't think
So basically just all maths.
all maths, yeah.
Okay.
We won't ask you to prove mathematical theorems, because it doesn't
Okay.
make any sense, right? It's like
Yes.
asking a how do I put this? Asking a fisherman to fire a cannon. That doesn't make any sense, right? I mean, yeah.
Yes. Okay. Thank
Because
you.
if you can do the algebras, that's fine. That's fine for us, I think. As non-engineering students, even most of the engineering students don't need the proofs. They simply don't care about the proofs, okay? If you're a mathematician or a physicist, then you should care about the proofs. So don't worry about, proof-based questions or questions where you will need to memorize stuff and, just vomit in the exam. Don't worry about those things. But you should know that, yeah, there is some sort of a proof. That's the point of showing you this whole jargon. That's it.
Thank
Okay,
you.
so any questions so far? Okay, if not, let me define one last thing, and those are called sorry, I do think I have a throat infection. I don't know, I can't talk properly. Thanda lagse, I guess, not COVID. So yeah, the last thing, disjoint sets. What are disjoint sets? Well, if you have two sets, let's say A and B, and if they don't have any element in common, then they're called disjoints. Okay, so one simple example can be something like this: 1 and 2, B can be A, B, 3. As you can see, there is no element in common between these two sets, so we call them disjoints. And a diagram will look something like this between these two sets. There is no overlap in between them. And if you take another set, let's say C, that has 1 and capital A, C and A are not disjoints because we have one element in common in between them. Not disjoint. But A and B, they are disjoint. C and B, well, they are disjoint as well. And if you want to put C in this diagram on the right side, then C would look something like this. This is C. And this is the part that we call an intersection, that we'll discuss in a bit. And it's denoted by A intersection C. This symbol reads as intersection. We'll talk about it very soon. I mean, yeah, within a few minutes or so. Okay, so any questions from disjoint sets? Okay, so I think we defined a lot of the stuffs regarding sets, all the basic stuffs. Now what I want to do is that I want to introduce some basic set operations. The first one is called an union of sets. So what is a union? Let's say you have set A is equals to 1, 2, A, B. B equals to capital A, small a, 2, and C equals to alpha, beta, and gamma. The union of sets is denoted by this. It's called a cup symbol. If you are someone who's familiar with LaTeX, you will type a /cup to implement the symbol. I don't know if it has any separate name of its own, but I call it a symbol of union. It's a big U, that's it. So when I say A union B, this symbol really instructs you to put all the elements of A and B together in another set. So this will look something like this: 1, 2, A, B, union with capital A and 2, and the resultant set will be this. Notice that even though A was a common element, we wrote it once only. Okay, so
Sir,
yeah.
I have a question.
Yeah.
স্যার এখানে তো দুইটা টু আছে, তাহলে আমরা একটা পিক করব না?
Oh yeah, we should pick one. I wrote the last
Okay,
one,
sir.
yeah, by mistake. Thank you.
Okay, sir.
Yeah. So this is how you do union, and if you want to have a union of 3 sets like this, A union B union C, well, it will look something like this. It's pretty simple. C is what? Alpha, beta, gamma, right? And just collect all the elements. If an element is there in more than one set, just write it once. For example, this 2 and A are over here and here, but we're writing it only once because a set like this really doesn't make any sense. Like, this is already there, so what's the point of writing it again, right? So that's why we don't write it.
স্যার এখানে তো দুইটা থাকলে একটা কমন নেওয়া হচ্ছে, তাহলে ইউনিভার্সাল সেটে কি শুধু দুইটাই নেওয়া হবে নাকি একটা?
একটা সেটের মানে আমি এইভাবে বলতে চাচ্ছি না যে সেটের সব এলিমেন্ট ইউনিক। হ্যাঁ, যদিও এটা ট্রু, মানে there is no point in writing things like this A, A, right? Because তুমি তো অলরেডি একটা এলিমেন্টে দেখাচ্ছ যে এটা আছে, what's the point of writing it again, right?
কারণ ইউনিভার্সাল সেটে জাস্ট একটা আসবে।
যে কোনো সেটেই ইউনিয়ন নিলে যে কোনো টাইমে, ওকে? মানে তোমার একটা সেটের ভিতরে একই এলিমেন্ট দুইবার কখনো লেখা হয় না। ইন দ্যাট সেন্স তুমি বলতে পারো একটা সেটের এলিমেন্টগুলো ইউনিক আর কি, unless there are some other complications, involved. So this is what this is now: alpha, beta, and gamma. This is how union works. So if you want to see this thing diagrammatically, we'll with diagrams like this. Diagrammatically, yeah, I always forget that word and the pronunciation. Yeah. So this is A and this is B, let's say. And what is A union B? With the help of diagrams, A union B is something like this. What is this color? Is it pink? Maybe golapi, I don't know. So this is your A union B region. Initially they might be disjoints, but once you unite them, this is the thing, this pink shaded region. You'll have elements of A and B, both of this. Okay, any questions regarding set unions?
নো স্যার।
Yeah, কারো কোনো কোয়েশ্চেন ছিল? আচ্ছা, যদি না থাকে, then let's move on. Then I want to talk about intersections, or set intersections. So they are denoted with this symbol, intersection. And if you have two sets, A intersection B, this symbol tells you to find the common elements between A and B. Let's say, take an example, 1, 2, 3. b equals to 4, 2, 6, c equals to alpha and beta. Now if I say what is the intersection b, you write a 1, 2, 3 intersection with 4, 2, 6, and if you
2.
use the definition you can easily see this is just 2, right? This is the intersection. With the help of diagrams, well, this is A and this is B. This is the intersecting region, or the region of intersection. And if you take this particular example, well, this is where 2 will live because he is in both sets. And what about this intersection, A intersection C? What should be the result? Can anyone tell
set.
me?
Sir, null set.
Why?
Cause there is no common element
Okay, yeah.
in
There is
both of
nothing
them.
in common in between them, yeah. So that's why the result is a null set. And again, if you recall the definition of disjoints, these two sets are disjoint, like this, A
Yeah.
and C. Okay, that's good. Now, any questions from set intersections?
No, sir.
Okay. Now let's talk about another operation that is called a set difference. So let's say you have a set A and you have a set B. The set difference is given by this backslash symbol. Some texts use this symbol as well, A minus B, but I don't like it. You can use it, it's fine, but don't think of it as some sort of an ordinary subtraction. So that's why I prefer this one, but you can also go for this one. So what does this tell us? Well, it tells us to take all the elements of B and just get rid of them, put them in, dump. And if there are common elements between A and B, get rid of them as well. Let me show you an example, and I think that will make more sense. So let's take A equals to A, B, C, D. B equals to capital A, small b, and 1. And let's take another set C, alpha and beta, let's say. So what is A set difference with B? What is this quantity? Well, let's write this thing in full form and then we'll talk about it. So this symbol here tells you to get rid of all the elements that is inside B, right? And if there is something in common in between these two sets, get rid of them as well. So first of all, we will have to get rid of A, small b, and 1, right? But small b is a common element in both of the sets. So what does this set difference tells us to do? It tells us to get rid of them as well. So if we get rid of all these elements and the common element too, we just find A, C, and D. So the result is A, C, D. Does that make any sense?
স্যার বি এর থার্ড এলিমেন্টে কি লিখেছেন বোঝা যাচ্ছে না।
Oh, the third element was 1. Like,
Oh, 1.
yeah.
Okay.
So does this operation make any sense? Do you get it? Or do you have any questions? If you have any questions, please ask. Okay, so you can think of it, think of this thing in another way. Okay, that is, focus on the set on the left and find all the unique elements that are not in B. That's another way to think of it, because if you take A is not in B, right? Small a, It's not in B because B consists of capital A, small b, and 1. What about small b? Small b is there in that set, capital B, right? What about C? I mean small c. Small c is not there in capital B set. Similarly, small d is not in capital B set. So the unique elements that are not in capital B are A, C, and D. So you just find them out, and that's your result.
Then one add হওয়ার কথা ছিল তো স্যার, A, C, D and 1 elements.
Look at A. A doesn't contain any 1.
Oh, sorry.
I'm saying find all the elements or all the unique elements in A that are not in B. And
Yes, sir.
if you have any elements of B, you know, you just get rid of them. Get rid of everything. I mean, B is just, you know, being put to garbage. And তুমি B কে ডাম্প করতেছো বেসিক্যালি। B এর ভিতরে যা আছে সব সরাই ফেলতেছো, আর তুমি দেখতেছো A আর B এর ভিতরে কিছু কমন আছে কিনা, যদি থাকে সেটাও তুমি সরাই ফেলতেছো। That's how set difference works. Is that okay?
Yes, sir.
Yes, sir.
What about A set difference C?
স্যার যেটা ছিল সেটাই থাকবে, A B C D।
Exactly. Because there is no element is common in between A and C, right? All the elements of A are not in C. I mean, none of the elements in A are in C, so the result is just A, B, C, and D. All right. Okay, so I think we are almost done, and the last thing I want to talk about is the set complement. So let's say you have a universal set U, and that universal set can have subset, let's say A. Then
স্যার
হুম?
এর আগের সেটটার যে অ্যানসারটা বলেছেন এখানে এটা বাদ যাবে না, স্মল এটা?
কোনটা? না, এটা আলফা, এটা A
কেন?
না।
ও আচ্ছা আচ্ছা, আলফা। ও
Yeah.
সরি, মাই মিস্টেক।
It looks like A. Yeah, sorry, my handwriting is bad. Yeah, so I mean my handwriting is kind of trash. I don't know. Yeah, so yeah, we were talking about set complement. So let's say you have a universal set U and a subset of that universal set A. So let me just write A is a subset of U. Then the complement or the set complement of A is denoted by A prime or AC. You can use either. I'll go for A prime for now, but maybe sometimes I'll use AC. So this C means complement. Okay, it's denoted by this and defined by the following. So the complement, you know, you can also write it as A prime is equals to the set difference between the universal set and the set itself. This is the complement. And if you want to take an example, well, let's say 1 2 3 4, let A be 1 2, then what is AC or A prime? We only learned set difference a few minutes ago, but can anyone tell me what this is?
Okay, sir, it's 3 and U.
That was 4, but yeah, it looks like a U. Sorry, again, my handwriting is pretty much trash. So yeah, this is your set
Sir,
complement.
এটা U না?
Yeah, I mean, I wanted to write it. I wanted to write it as a 4, but yeah,
Okay,
U is also
okay.
fine.
Okay,
I mean, yeah, I
sir.
should write 4 like this, right? Like
It's okay,
this,
sir.
like this. I don't know. Yeah. আই মিন আমি লাস্ট 2 বছরে খাতায় কোনো কিছু লিখি নাই, যা লিখছি
জি
ট্যাবে
স্যার,
লিখছি।
আমার এইচএসসি টাইমের কথা মনে পড়ে, সরি এসএসসি টাইমের কথা মনে পড়ে গেল স্যার।
সো হ্যাঁ, এখন খাতায় লিখতে গেলে অসুবিধা হয়, আর বাংলা লেখাও মোটামুটি ভুলে গেছে। হ্যাঁ, ইটস নট সামথিং টু বি প্রাউড অফ, বাট মানে ইট শুড বি এ শেমফুল থিং, বাট সামটাইমস আই এম প্রাউড অফ ইট আসলে। হ্যাঁ, যে আমি এখন লিখতে পারি না ঠিক
আর
মতো।
বোঝা যায়, কিন্তু সব লিখাই বোঝা যায়।
আচ্ছা, ওকে, okay, fine. So this is how set complement works. Okay, and okay, any questions so far before I move on to other stuffs? Yeah.
Sir, can you define set complement one more time?
Oh, let's say you have a universal set U, and let's say you have a subset of that universal set. Okay, the set complement is just defined with the relation that is written over here, the set difference between the universal set and the set itself.
Okay.
So if my subset is A, then A's complement will be given by the set difference between the universal set and the set A. And if I try to draw a diagram like this, let's say this is my U, let's say this is A, because it's a subset, then the set complement is just this region over here, because you are getting rid of all the elements in A, right? That's what set difference means.
Okay, thank you. I got it.
Okay. Any more questions from anyone? Okay, so this is it. We are done with sets, but before I finish things off, I know I showed some Venn diagrams, like these diagrams are called Venn diagrams, but I think I should just, formally show you guys what is a Venn diagram or what is a Venn Euler diagram. These diagrams can be thought of as tools to visually aid us, because all this talk about objects, collection of objects, these are pretty abstract. So these diagrams are some sort of a tool, a visual aid tool, so to say. So how do we represent things in Venn diagram? Well, pretty easy. Let's say you have a set A. You can represent this set as a box like this, a circle like this. I don't know if you want to have a star or something. If you're good at drawing stars, then the star, I don't know, and it really doesn't matter. So the most common notion is to use these circles, so let's stick to that. So this is how you represent a set in a Venn diagram. Now let's say you have two sets and A is a subset of B. How to represent this? Well, let's draw B first. Okay, this really doesn't look like a circle, so let me just use this thing. Yep. So this red shaded area is A, and this yellow shaded area is B. As you can see, B is containing A, so this is how we represent A as a subset of B in the language of Venn diagrams or Venn Euler diagrams. How do we represent A intersection B? Draw two circles like this. Let's call it A, let's call it B. Then this shaded region will be my A intersection B thing. Okay. Now, one more example. Let me use these things, though they take a bit of time, but the figures are good. So, should I call them? Let's call it C. This one as B. Then this one as A. And this is our universal set. Okay. So even though this is not a pretty good color on a dark background, but it will have to do for now. This region is just a intersection B. This is C, as you can tell. If you want to denote a region that is given by U difference C, or so to say C prime, or the complement of C, then this will be, you know, this whole area. Like, it will also consume A and B too. And stuffs like this. If you want to show A union B, this will be your A union B, you know, like a double donut but with no holes. So this is the pretty basic idea of Venn diagrams. And if you forget about this C, let's say the C is not there. Okay, let me just erase the whole thing. And let me draw two circles again. Yeah, please ask.
স্যার ভুলে প্রেস পড়ে গিয়েছিল।
Oh, okay. So if you want to have this sort of a region, let's say U difference with A union B, then this will be your region. This pink shaded region is the region for the complement of A union B, or you can write it as A union B complement. So using Venn diagrams, you can try to, you know, visualize these stuffs, and in some cases it might help. Any questions so far regarding Venn diagrams?
No, sir.
Okay, so before I finish, there is a couple of remarks. You don't need to know the proof of these things, but you can easily figure them out by using Venn diagrams or any particular examples. The first remark is that A unioned with A complement or A prime is just the universal set itself. Because it's pretty easy. If you just go back to the previous page and forget about this B over here, then this pink shaded region would give you A complement, right? Because it's U difference A. And now what I'm trying to tell you is that, oh, take a union of this A complement with A itself. So that means you take all the elements inside A and all the elements inside A complement. So that will cover up the whole rectangular region, and you get the universal set back. So try to do these things via diagrams. I don't know if you want, but these are the remarks that you should know, and this will help you in the long run. Then the intersection between A and A complement or A prime is null set. Then the complement of the universal set is by definition a null set, because when you define a universal set, it means there is no other set that will contain the universal set, because if it does, then it's not an universal set. Let's say you are talking about this rectangular region over here. If you drew another region like this and called it V, then this U would not be a universal set, because it's a part of a larger set. Okay, So this is by definition U prime is just, or U complement is just null set, and the complement of null set is U itself. It's pretty easy to see. Just what is a null set prime? By definition this is universal set, and you get rid of all the elements in null set. But what are the elements in a null set? There is nothing, right? So you just get U back. Okay, then the complement of a complement, or the complement of the complement of A, is just A itself. This is also easily seen by Venn diagrams, or if you want you can use the definitions of the complement of a set to show that. And lastly, A difference B is the same thing as A intersection B prime or BC. That means B is complement. Okay, so these are the things you should know, but it's a good idea to just draw some Venn diagrams and try to get a feel for it. In that way you will get some ideas of why these things are true. You don't have to know a rigorous mathematical proof, but I recommend that you do draw some Venn diagrams and try to understand these things, and if you want you can discuss it with me after the class or in the Discord. It's up to you. Okay, so someone raised a hand. Please speak.
Sir, would you please স্যার 4 নাম্বারটা একটু আবার বলবেন?
4 number means হচ্ছে তোমার null set এর complement হচ্ছে গিয়ে the universal set, because what is the definition of a complement of a set, right? You take the universal set and you take the set difference between the universal set and the set that you were talking about. Now when I'm talking about the complement of a null set, by definition I have to write what? U set difference with null itself, right? That means the null set itself. But null set is what? It doesn't contain anything, so it just gives you the universal set back. You are not getting rid of anything, so whatever you had in hand you just get that back. Does this make any sense?
Yes sir.
Okay,
Thank you.
yeah, so do one thing, maybe draw some Venn diagrams and try to make sense of them. Okay, and finally I want to give you guys some exercises. Most probably they will be in your homework after we are done with 2 more lectures, because I have only given 2 lectures. There are 2 more lectures, and after that you'll get an assignment. So these are some exercises for you that you can practice. I'm giving you a heads up. So if A is a subset of B, then this implies, so this right arrow means implies, this implies A intersection with B is just A. 2. If A is a subset of B, this will also imply A union B is just B. 3. If A is a subset of B, then B's complement, or B prime, is a subset of A prime. 4. If A is a subset of B, this will imply A union B set difference with A equals to B. The first 3 are pretty easy. Just use Venn diagrams. Just use the Venn diagram and you will see that these results will pop out. Okay, and the fourth one, you can use a Venn diagram to do it as well, or you can take any particular example where A is a subset of B, set things up that way, and check the left hand side and the right hand side. That means check B, that's the right hand side. But I mean, what you can do is that you can take A to be some set 1 2 A B, and this is a subset of B, right? So let's say 1 2 A B C D E, and you know now that what is B, what is A, so I think you can do this stuff, right? First you have to compute B difference A, then you have to do a union of A with the difference of B union A, B difference A. You take their union, you will get back B. So try to do these stuffs, and they might be in your homework exercises, some of these stuffs. I mean, it's just 4 problems, so try to do them maybe. Yeah. হ্যাঁ বলো।
আমরা কি ডায়াগ্রাম ইউজ করে করব নাকি ম্যাথমেটিক্যাল টার্ম এন্ড ডায়াগ্রাম দুইটাই?
যেভাবে সুবিধা হয়, but try to make some sense of these things. It's important that you try. Okay, তোমাদের 100% সাকসেসফুল না হলে হবে, but I want you to try. ভেন ডায়াগ্রাম যদি ইজি লাগে সেটা করতে পারো, যদি একটা পার্টিকুলার এক্সাম্পল নাও সেটা দিয়েও করতে পারো, বাট ট্রাই টু গেট এ ফিল ফর ইট, কারণ এগুলো যদি নিজে প্র্যাকটিস না করো তাহলে পারবা না পরীক্ষাতে বা অ্যাসাইনমেন্টসে।
এক্সামে কি এইটাই থাকবে?
এই টাইপ থাকতে পারে, আমরা হয়তো বা a ইকুয়ালস টু সামথিং b ইকুয়ালস টু সামথিং দিয়ে দিব, তারপর এই জিনিসগুলো দেখাইতে বলবো যে এটা দেখাও বা এটা কেন হয়েছে, একটা লজিক্যাল এক্সপ্লেনেশন দাও। ওকে, সো সিফাত।
Sir, what are the elements of universal set?
Well, depends on the subsets that you are working with. There is no unique definition of a universal set, right? I mean, if you can have 2 sets, let's say A and B, and that contains, let's say A contains all the odd numbers, all the odd integers to be precise, and B contains all the even integers, and what is the universal set in this case? Well, the universal set can be the set of all integers, the universal set can be the set of all real numbers. Okay, so there is no unique definition for a universal set, but once you are given some sets, you can always say, oh, these sets might be a subset of a bigger set, and that bigger set is the universal set.
Okay sir, thank you.
স্যার হোমওয়ার্কটা আমরা কোথায় সাবমিট করব?
Okay, let me give you the homework. Let's talk about this logistics things later. Okay, so any more math questions like the stuffs that we discussed today? Is there any other questions regarding that?
স্যার রিমার্কস গুলো একটু আবার দেখাবেন, আমি একটা স্ক্রিনশট নেব।
Oh, I'll provide you guys the PDF. Okay, I uploaded the PDF from last lecture. I mean, I forget it sometimes, so just give me a reminder if you don't get this PDF by 10 p.m. today. Just check BUX at around 10 p.m. and if it's not there, just mention me at Discord and say that you're supposed to upload the PDF. You'll get the PDFs, okay? Don't worry about it.
Okay, done, sir.
Okay, so if there are no more questions, then I want to stop recording. Should I
Sir,
stop
can you
recording?
explain family sets once again?
Okay, so family of sets, right? So family of sets means, let's say you have a set, but this time the elements or some of the elements are sets themselves. Okay, let's not write 3, let's make it an 8. You see, this set A contains an element A, small a, but it also contains sets like this. So in this case, this is a family of a set. This A is called a family of sets. In some book, it's also called a set of sets.
On a set or set?
Well, the elements are now, some of the elements are now sets themselves, so that's why it's called a family of sets or a collection of sets. Okay, any more questions? If not, I want to stop the recording. Is that okay?
Okay, sir.